So continuing with the M2 International January 16 paper for Edexcel. It's a 10-mark question, centres of mass. It's all basically what we've got is a mass of Km placed here. It's uniform, so that means that we can regard these as having the same mass because they're the same size, these two rectangles that are placed together. It's told out two identical rectangles. So we can call those m over 2 and m over 2. I mean, often we talk about the mass being proportional to the area, which of course it will be, but it's much simpler in this case to use the fact that they're going to be the same area, obviously, and therefore same mass. And because the whole mass is m, each individual one is m over 2. And then we've got km there. And just to look ahead a little bit, what's happening is we've got the things suspended from A, and we're given the angle that this makes, so we know where the centre of mass, or at least the centre of mass, lies along this line, x bar and y bar, because it must go through the centre of mass, the vertical line. So we're going to use that fact to work out what the value of k is. But I think we need to get expressions for k, for x bar and y bar, the centres of mass, before we proceed really. I tend to like to put things in a table with this type of question when we've got an x bar and a y bar involved. So separate masses, we've got the m over 2 and another m over 2 plus a km, and then those two added together, the composite mass, the whole thing together, is then going to be m plus km, so that's m times 1 plus k. Let's consider the x and y coordinates for these. The x coordinate is, let's make that for this one, 3a over 2. The y coordinate for this one is obviously a over 2 because halfway up. Then let's consider this one. The x coordinate is obviously that distance there, which is a over 2. The y coordinate will be this a plus this halfway up the 3a, which is 3a over 2. Combined is 5a over 2. Now, much simpler to find km, that's basically 3a along and 0 up, because it's placed on the line FE, and we've got x bar, y bar. Right, so taking our moments equation, if you want to write it in the actual quote, the formula that we're actually using, I'll do it for the x one, I probably won't bother for the y. So sigma xi mi is equal to x bar sigma mi. Basically it's saying that this times this plus this times this plus this times this equals this times this, and similarly for the y coordinate. And I haven't bothered putting in g. You are taking moments really, but g would cancel anyway. So we've got m times 3a over 2 plus, well, that's m over 2 of course, m over 2 times a over 2 is equal to plus km times 3a is equal to m 1 plus k times x bar. So that's 3a over 4m plus a over 4m plus 3am is equal to m 1 plus k x bar. We can easily see that x cancels, by the way, so might as well do that now. So we've got, if these two combined, these two combined obviously just make a, so we end up with these, oh, I've left the k out there, so these make, that makes a plus 3k over 1 plus k. Let's tidy it up a bit. X bar equals to a 1 plus 3k over 1 plus k. Okay, that's better. Okay, so let's do a similar thing for the y. We have m over 2 times a over 2 plus 5a plus m over 2 times 5a over 2 equals to m1 plus k times by y bar. Now combining these two here, that's again, first of all we can see m cancels again, and then combining these two together we're going to get those are equal to 6a over 4, 3a over 2. So that will be, simplify it down to y bar is equal to 3a over 2, 1 plus k. Okay, so that's our y bar. Right, so we've got expressions for x bar and y bar. Now I think I might as well go back to the actual shape. I've got an enlarged version of the shape here because it's too much going on in a small diagram here, so I've blown it up a bit. So then what we've got is a vertical line that goes through x bar and y bar. Let's just mark on some things on this diagram. Let's mark on the vertical. Okay, mark it on nice and do a nice tidy diagram. It's going through A, it's been suspended from A, and it tells us this angle here, tan theta, is 4 over 7. And now we know the centre of mass. Let's just say for argument's sake the centre of mass is here, say. Don't know whether that's anything like to scale. Then we know that's at x bar, y bar, but we know what we have expressions for those. Now let's just mark on our distances. Let's just do this. Let's change colour now to blue. Let's change colour to blue. This distance here is obviously just x bar. So that distance we know is the distance there. However, this distance here, because I've taken moments from the bottom, some of those of you who looked at the bar scheme have taken moments from the top. It might be slightly more efficient, but sometimes it works like that. You get into a question and realise you might have been quicker doing it slightly another way. So I've taken moments from the bottom. I've got my y bar is this distance here, but I know this distance here is 4a. So let's call this distance, I don't know, call it d. So we have d equals to 4a minus y bar. So d equals 4a minus y bar, which is 3a times 2, 1 plus k. If I multiply that out, I get 8a minus 3a, which is 5a, plus, and then it's 8ak, all over 2, 1 plus k. Okay, so I've now got an expression for x bar and d, and we know that tan theta equals 4 over 7, but we also know using just basic SOHCAHTOA geometry in this triangle here, that that's equal to x bar over d, opposite over adjacent. Right, so that's, I'm going to avoid getting a stat fraction, I'm going to write that as 4d equals 7x bar, rather than just go ploughing into it with fractions over fractions. Let's do it like that. So we got 4 times by 5a plus 8ak over 2, 1 plus k, equals 7 times the x bar, which is all the way over here. Got a while since I've done it. That's 7a 1 plus 3k over 1 plus k. Now I can see some cancelling again that's going to go on. I can cancel the 1 plus k from the bottom. I can cancel the a because that's in everything. And I can also replace this 2 here, divide through by 2 there to get a 2 here. So multiplying that out, I get 10 plus 16k is equal to 7 plus 21k. So that gives me 5k equals 3, so k equals 3 over 5. Quite a lot of fiddling around with that, not too bad, quite a long question. And so it's good that we've taken our time with it, got to the answer. Let's have a look at the next question there. Okay, so this is a statics question. We've got a hinge, it says somewhere at A, hinged at A. Now normally I would just make this horizontally and vertically here, but as we'll see later in the question, they've directed us to consider parallel and perpendicular components of the rod, of the hinge, and it also talks about the angle with the horizontal of this. So this angle here being phi there. So let's just deal with that. Let's just worry about that later. Okay, looks a little bit tricky, but we'll see. We've got masses of mg there. I think it says there's a mass of mg at B somewhere. Yeah, there. And we've got the fact that it's a uniform rod, so that's A along mg, and the mass of the rod is 3m, so the weight is 3mg. Right, now, we don't really need to worry about the reaction force if we take moments about A. It's almost always a good idea to take moments about a hinge in these types of questions, because the direction then of the force on the hinge really doesn't matter, and we can deal with that later. So we're going to take moments about the hinge. Now, I think I prefer to actually, rather than talk about perpendicular distances, which is not particularly difficult to do, I prefer to actually look at this in a way by way of components. So I'm going to split the 3mg and the mg into components parallel and perpendicular to the rod. Now, perpendicular to the rod is what really matters, because that's the thing that's going to have the turning effect. This angle here is theta, so this component here is 3mg cos theta. There will, of course, be a component of 3mg sine theta, but that won't figure in the moments equation. And then similarly, we've got a component of mg cos theta here, and the bit parallel to the, so it's mg sine theta. Cos theta because it's adjacent to the angle there, it's next to the marked angle, and sine theta because it's away from the marked angle like that. So, okay, now let's just do it then. We should be able to take moments about A. Don't forget force F, obviously. We can take, but that's already perpendicular to the rod, so we can take moments about that pretty easily. So the moment of F is F times B, because that's the perpendicular bit, distance mark there, B, equals, and then we have the 3mg component of the force, which is perpendicular, cos theta. Now that's at a distance A away. Then we've got the mg cos theta force, but that's at a distance 2a away. And I think that gets us to where we want to go, because that just dividing gives us f is equal to 5 mga over b cos theta as required. Okay, so that's the first part, nice and easy part. Part B, now we're talking about hinges and all kinds of stuff. So I've just marked on the reaction force. Now, as I say, because it's given me an angle, I wouldn't normally, unless it asks for the part of the question, I wouldn't normally mark the R as being in a direction like that. I'd normally mark it in whichever, probably RY and RX like this, and then work that out, and then if it asks for an angle, deal with that right at the end. But because it talks about the angle being phi here, then we can say that we can basically look at the components of these parallel and perpendicular to the slope, and we can maybe then get some kind of clue on what they're talking about in part C, about ranges of values of B in terms of A or C. Anyway, let's just split the R into the perpendicular and parallel components. Well, this angle here is actually theta, phi minus theta. So the component which is perpendicular to the rod here will be essentially R sine phi minus theta. And then there will be this bit here, which will be R cos phi minus theta. Well, how that's going to help answer the question, I'm not sure, but hopefully this will take us somewhere. Right, because it talks about things being parallel and perpendicular, I'm going to resolve parallel and perpendicular to the slope. So resolving parallel to the slope, the good thing about this, of course, is f doesn't figure in our equation at all. Resolving parallel to the slope, we have mg sine theta, the component I drew earlier on, plus 3mg sine theta is equal to the parallel component, phi minus theta, let's write that out again. So R cos is equal to 3mg sine theta plus mg sine theta. So R cos phi minus theta is equal to 4mg sine theta. That's the perpendicular, that's the parallel component. Let's mark it on nicer than that. This is actually the parallel component here. Okay, so if I resolve perpendicular to the slope, it's perpendicular to the slope, I've got my R sine psi minus theta, which is the bit I want, plus f, because that's now figuring onto it there, is equal to the two forces acting in this direction, which are 3mg cos theta plus mg cos theta. So that equals 4mg cos theta. let's rewrite this. R sine minus theta is equal to 4mg cos theta minus f, and that equals to 4mg cos theta, and we've got f from before, we found it, we proved that, 5mga over b cos theta. Now, again, this is the component perpendicular, because it, by definition, because it's what I've got here, it's the same as that. So this is the component perpendicular. Just to make it clear to the examiner, we actually have answered the question, and we know we've answered the question. That's the bit. Component perpendicular is equal to that. Right, okay, so that is this part, that's part B done basically. Part C, it says, hence or otherwise find the range of values of B given your answer in terms of A. It has told us some information about phi here being greater than theta. You'll notice that no matter what the value of phi is, this is always positive. Okay, but this isn't always positive. Obviously, if phi were less than theta, this would be negative, which would basically mean that the component perpendicular would be in the opposite direction. But they've said that phi is above the rod, so that means that that's positive. So what that basically means, r sine, because phi is greater than theta, r sine phi minus theta has got to be greater than 0, otherwise we'll be taking the sign of a negative, which is negative. So that must mean that 4mg cos theta minus 5mga over b cos theta has got to be greater than 0. Okay, so hopefully this is going to work out nicely. We're going to do some cancelling again, mg and cos theta, and a, no, not a doesn't cancel obviously, but mg and cos theta will cancel. It's m and g and cos theta. Now obviously we've got to be, normally we'd have to be careful cos theta if we thought it was negative, but it definitely isn't here because theta is acute, so there's no problem with reversing inequalities or any such thing. So that gives us that 4 has got to be greater than 5a over b. So that gives us that b has got to be greater than 5a over 4. Again, because a and b are all positive and all the rest of it. So that is question 6 done. I did think that was a little bit tricky towards the end, a little bit confusing. Okay, last question. Oh, relief. Nice projectiles question. I often say to my students I teach that I do prefer mechanics when things are moving. Kinematics always more easy to get an angle of, really. Yeah, and I think this hopefully will be the case here too. Right, we've got, it's very clear from the diagram what's going on. That's helped us a lot. An unknown u, an unknown veta, but we're told that t equals 2 at this point. I might resolve these two into two different bits. 6 sine 45 and 6 cos 45, which will be 6 over the square root of 2, 6 over the square root of 2. Or if we have been particular about rationalising, that makes it 3 the square root of 2. Makes sense because it gets rid of the fraction, doesn't it? Times by square root of 2 on top and bottom. 3 the square root of t is the horizontal and vertical components of this. That's going to help us a lot because we're going to find a value of theta I think it's going to be quite a nice start to this question because the horizontal speed is constant. So u cos theta must be equal to the 3 the square root of 2 that we had here. So the horizontal speed is constant. Okay. Part B, oh sorry, part B, getting ahead of myself. If we look at the vertical component, let's apply V equals U plus AT, because that gives us everything that we really want. The initial, because we're doing this vertically, is U sine theta. Okay, the final, be careful, it's going downwards, so it's minus 3 the square root of 2, because it's going downwards. But so is gravity, so it's minus G times 2, because we're told it takes 2 seconds to put into there. So that gives us U sine theta is equal to 2g minus 3 square root of 2. So, yes, it's not going to work out too badly at all. If we divide these two, we're going to get tan theta. If we divide those, tan theta is going to be, which is sine theta over cos theta, is going to be 2g minus 3 the square root of 2 over 3 the square root of 2. Okay, now if I find the inverse tan of that, I get theta is equal to 74.6 degrees or 75 degrees. 2 or 3 significant figures. Okay, theta is 74.6 degrees. And that is the first part done. Not too bad. 6 marks come by easily compared to what we were having to sweat over in the last question. Part B, the kinetic energy of B at its highest point. They just want us to recognise that there's no horizontal velocity, there's no vertical velocity there. The horizontal is constant, which is 3 the square root of 2. Okay, we're told that we must be told the mass at some point. Yeah, the mass is 0.7. So the kinetic energy at highest point is going to be equal to half times 0.7 times by the speed, and it's only that, 3 the square root of 2 squared. Working that out, it gives me 6.3 joules. Okay, so nearly there. Part C. Right, what are they on about here? For an interval of t seconds, the speed v of p is such a v is less than or equal to 6. So just testing things in a slightly different way here. When we've got the speed, we've got the speed here as 6. Let's rub some of this off now. We don't need it anymore. We've got the speed of 6 here. Okay. Now anywhere above that, the speed would obviously be less because it's gaining gravitational potential energy, so it must be losing kinetic energy. The speed is getting less as we go upwards, obviously. So we know that it's got to be between those two times. We know that t equals 2 here at this time, and the speed is going to be less than 6 all the way through that point. So if we can work out the time here and just take it away from 2, we'll have the time for which the speed is less than or equal to 6. Well, by symmetry, it should be also clear, and by use of symmetry, by using energy, whatever, because it's got the same gravitational potential energy, the speed must be the same, but this time upwards. Okay, and we using symmetry, because we know that this is all the same here. Lots of ways we know this. We know that this is going to have to be 3 to the square root of 2 here, and this is going to have to be 3 to the square root of 2 here, because the speed horizontally is constant, which is 3 to the square root of 2. So the speed upwards would have to be 3 to the square root of 2 as well, so that the velocity upwards, component of velocity upwards would have to be 3 to the square root of 2, so that the speed is 6. Or just using symmetry, we know it's got to be 45 degrees. Okay, so lots of reasons why we know that. Okay, so I don't think this is going to be too bad, because all we have to do is find t at this point here. What do we know? We know that u is equal to as we've said here, u is equal to u sine 30, which is equal to 2g minus 3 the square root of 2. So u, what I mean by that is our initial, because we're going vertically. And then v is equal to 3 the square root of 2. And we want to find out t. And we know obviously the acceleration is minus g. So if we apply v equals u plus at, we'd have the final velocity vertically, which is 3 the square root of 2, is equal to the initial velocity, which is 2g minus 3 the square root of 2, minus g times t. So working that out, that gives us gt is equal to 6 the square root of 2 minus 2g. So t is equal to 6 the square root of 2 minus 2g over g. And all working that out, that comes to, I just realised I've got those the wrong way around, obviously. gt comes over the other side, so that makes it 2g minus 6 the square root of 2. So that's 2g minus 6 the square root of 2 over g. And working that out, that comes to 1.13 plus a load of other stuff. We're only working in 3 significant figures. So t is going to be as we say, the difference between these two times, which is 2 minus 1.13, which is equal to 0.87. Okay, and that is the paper done. I hope you enjoyed that. Not the easiest of questions, some of them, but I think the last question was a relative treat. Okay, that's January 16 done.